In this tutorial, our learning objective is to be able to compute the arc length and the sector area that has been created by an arc on a circle, okay? So let's say if this is my diagram, that is a circle with a center at O right here, correct? And then there are 2 points on this circle, the point P and Q. And then we know that when you join these 2 points, P and Q, such that you remain on the boundary of the circle, right? And you connect them such that you obtain a curve like PQ as shown in this green highlight, then this is called an arc. And in this case, we are saying that this is a minor arc because you are connecting the shorter sides between the point P and Q, right? And the angle that this arc PQ creates on this circle is the angle, let's say x degree. This is the angle created at the center by this arc PQ. Okay. Now, before we go too far into the formulas for the arc length and the sector area, I also want to introduce one more term of the measure of an angle in a circle, right? And that measure is called the radians. It is specific to circles. We all have learned that so far. Degrees is what we use to define the measure of an angle, right? But when it comes to circle, we can define one more way of measuring angles, and that is called the radians. Okay, so let's say that you have a point A on this circle, right? And the radius is OA, right? Let's say this point A, it travels on the boundary of this circle and it completes one full revolution around the center and it comes back to its original point, right? When that happens, you say that the point A has traveled full 360 degree. But at the same time, you can say that one full revolution of any point A on a circle around the center also means that it is equal to 2 pi in radians. In other words, 360 degree is equal to 2 pi radians. That is how you define the linkage between the degrees and the radians. And that could lead to two different things. It could lead to that 1 degree is equal to pi over 180 in radians. Okay, that is when you simply divide both sides of this equation with 360 degree and get rid of the common factors, right? Likewise, if you would like to obtain a relation of how you define 1 radian, how much of that is equal in degrees, then you will say that it is equal to 180 over pi in degrees. So these are two critical points that you want to remember about the relation between 1 degree to a number of radians or 1 radian to a number of degrees for a circle. Okay, now let us talk about our concept of how do you compute the arc length and the sector area in a circle. So in this case, I am defining the arc length is, let's say it is denoted by term S, and the sector area, it is denoted by a term A. All right. And we are going to create a very simple table. It will be very easy to understand. So when we say that a circle has 360 degree, right? So when you complete full 360 degree by this point A, right? Then that means this is equal to the entire arc being the circumference of this circle, right? So 360 degree means the arc length is equal to 2 pi r, right? If you have just 1 degree, that means you're simply dividing both sides with 360, then you will say that this is equal to 2 pi r divided by 360, correct? Or when you simply multiply this whole expression with x degrees, then you will say that x degree is equivalent to an arc length that is obtained by multiplying this factor with the measure of the degree, okay? So this means that you have obtained that for x degrees, the arc length is going to be 2 pi r divided by 360 times x, right? Just like that, we will obtain the formula for the sector area. Using the same steps, you will say that when you have full 360 degree traveled, in that case, the circle itself is the entire sector, right? And when you have just 1 degree, then you will simply divide this pi r square with 360. Right? And just like that, when you have x degrees of a sector, then you will multiply both sides with x degree and you will say that x degree of a sector created by an arc PQ means it is an area of pi r square divided by 360 times x. So this is the expression for the sector area where angle x is measured in degrees. Okay. Now this is what you have obtained, the arc length and the sector area when you have defined your angle in degrees. When someone says, I want to define my angles in radians, not in degrees, then I will follow these identical steps here. And then we can obtain that the arc length S is equal to x times r, where x is in radians, it is the measure of angle, and r is the radius of that circle. Okay. We are not going to go through the details of how you came to this conclusion because we will follow the exact same steps. Instead of 360 degree, we will just replace that with 2 pi, and then you will follow these steps to obtain your final expression. So this is your expression when you say that x is in radians and r is the radius of a circle, then the sector length of an arc PQ will be defined by this relation. And likewise, you will say that the sector area A by x, when you have x is in radians, will be 1/2 times r square. So I will say at this moment, how you came to conclusion on these two expressions is also your very little homework assignment. It is absolutely simple. You simply replace 360 degree with 2 pi and follow these three steps. Okay. So with that, our objective was to understand how do you obtain the formulation for the arc length and the sector area. Now let us go take a look at some examples to best understand how to apply these formulas. Alright, so in this exercise we have three diagrams. Each one of these diagrams has one unknown value that we are supposed to find. Okay, so by taking a look at our very first diagram, we have that it is the arc length that is what we need to find. Okay, so arc length, we know that it is equal to 2 pi r divided by 360 times x in degrees. Right? Because we are given the radius in centimeter and we are given the included angle by this arc in degrees. Alright, so we will simply substitute these values. We will say that it is 2 pi divided by 360 times the radius, which is 60 centimeter, times x, which is 165 degree. Okay. So there are lots of common factors in the numerator and denominator in this case. So we get rid of 2 and 60 in the numerator with 360 in the denominator, and we obtain a 3 only, and 165 divided by 3 is equal to 55. So this is 55 times pi, because this pi remains as it is. So the arc length in the case of 1 is 55 pi in centimeter. Okay, it was very simple. Just substitute your values into the expression that you have for the calculation of arc length. Okay, take a look at the second problem. We have that arc length is equal to 2 pi r divided by 360 times x in degrees. Okay, we have everything except the radius. Okay, so let's substitute 135 pi, which is coming from here, is equal to 2 pi times r divided by 360, of course, times x, which is 300 degree. So let's get rid of the common factors. First we get rid of pi. Okay, so then we obtain that the radius is equal to 135 times 360 divided by 2, and then this 300 also goes in the denominator. Okay, so when you solve all of this mathematics, you will find that this value r is equal to 81 centimeter. All right, so this is the value that you have obtained as 81 centimeter. Okay, now let's take a look at our third problem. You are given the area in this diagram. The area is 3 pi centimeter square. You're also given the included angle by this sector, which is pi radians, and you're supposed to find this unknown, the r, the radius of this circle. Okay, so we say that the area of this sector is equal to 1/2 times r square times x, where x is in radians. So substituting the values on both sides, whatever we have been given, the area is 3 pi is equal to 1/2 times r square times x. The x is in radians, of course, so it is pi radians, right? So we'll just write pi here. Now let's get rid of the common factors on both sides of this equation. So pi is, we can get rid of simply, and then we say that 3 times 2 is equal to r square, or it implies that r is equal to square root of 6, and this is in centimeter. Alright, so using these three examples, it is not that this mathematics of cancellation or computation or division is important. It is that the relation of the arc length to the dimensions of any circle given, whether it is the radius or the angle that has been created by that arc. That relation is important to understand. We want to pay more attention on the process of how you obtain that relation. That is what we discussed in our first section of this tutorial, right? And then this is our last formula. With that, we will take a pause here, and it was our objective to introduce to you how to obtain the formulation for arc length and the sector area that has been created by an arc.